Welcome back to our second day of live streaming for Made in Brunel TV. I'm joined once again by my co-host Paramveer Bachu.
Hello.
Pav, how's it going, man?
It's going pretty well, I think.
Yeah, how do you think yesterday went?
Yesterday went really, really well.
Yeah.
It did. We got a lot of people, and I think we got some great stuff. So
yeah, no, I think it was really good yesterday. As I said yesterday, it's great to see students in and enjoying themselves and interacting and showing off their projects. It's a little bit of a cooler day today. We're streaming from a rather damp South Bank at the moment, but I mean, it has been unbearably hot.
I'm grateful for the temperature.
Yes.
The temperature is good.
Yes.
However, it is raining, but the temperature's good.
My toes are a little bit soggy at the moment.
Oh, okay.
So that's a little bit uncomfortable.
Yeah.
But no, today's going to follow a very similar format to yesterday. We're going to have some student interviews in the morning, followed by some student-led programming in the afternoon, and that will go from 3 till 5. You're going to want to stay for that because you're in for a treat, let me tell you that. But Pav, are you looking forward to that as well?
I'm very much looking forward to that. I'm probably going to go into the next room, sit down on the floor and watch that.
You're gonna eat some maybe hot wings?
Potentially, yeah.
Maybe?
Yeah.
I think that's a terrible idea.
Okay, so do I, to be honest.
I never want to see a hot wing again in my life.
No, that will make more sense later on, to be honest. But yeah. It should be good. I'm looking forward to everybody seeing that. So it should be honestly a really good day.
Wonderful.
You know? I don't think we'll get any people commenting on the weather like yesterday. So I think our max on the bingo is about 6 at the moment. If it warms up, we'll see. But other than that, it should be good.
Yeah, looking forward to it.
So, yeah.
Looking forward to it. We will be back in a couple of minutes for our first student interview.
So we're here with our first guest, Will Hardy, and we've actually got our first Viva presentation video of the day. So we're going to play Will's Viva video.
This is the HT3 tool changer and the subject of my major project this year. This is the enclosed version of the machine. This is the standard version and the version we're going to be taking a look at today. So, features of HT3. Well, the first feature, and probably the most important, is the tool changing. This allows the machine to swap tools and print multiple materials or colours in the same print. This is obviously a sped up version of the process, and what's happening is the tool head is swapping tools every couple of layers, so it's printing 2 layers of red, 2 layers of black, and layering them up over time. Taking a closer look at the mechanism now, on the left side you can see the electromagnet with the kinematic coupling in the form of stainless steel dowel, and on the right you can see the ball bearings, which are also stainless steel, and the armature plate which couples the electromagnet. Taking a look at another tool change here, and more specifically how we keep the nozzles primed to ensure they're ready to print when they're called upon. So this has been slowed down so it's easier to see, but right as the tool head moves in to pick up the tool, you can see the filament being extruded, and this is to keep the nozzle primed. Taking a look from another angle here, as the nozzle brushes over the silicone white, you can see it leaves the plastic behind, so now the nozzle is clean and ready to print. HT3 also has a removable steel build plate, and the bed is actually removable, which could be quite useful in an environment where you're trying to save every second you can, maybe on a production line or something similar. Taking a look at the 3-point bed leveling now, obviously this example is exaggerated. I put a big slant in the bed for the purposes of showing it off, but the way it works is it will always level the bed to be parallel to the gantry. The machine connects to Wi-Fi and can be controlled from your laptop or tablet. In terms of maintenance, there isn't too much to do, but you should understand how the Core XY motion system works. In a Core XY configuration, each motor moves the tool head diagonally. So in order to get X or Y direction, you actually need to have both motors moving at the same time. Now the benefits of this system over a Cartesian system is that you don't need to have any moving motors, you don't need the X-axis to carry the weight of the X motor, so both motors are stationary, and this means the tool head can move faster, which means faster prints. As for maintaining the belts, you just need to ensure they're correctly tensioned, and this is done by loosening the bolts that hold the motor to the mount, and pulling it backwards. You also want to keep an eye on the individual tool heads. Benefit of these is they can be taken off the mount, means you can get a better look at them and they are easier to maintain. The main thing to check is that they're still moving freely on and off the mount without too much resistance. There shouldn't be anything caught in the fan, and the nozzle should be clean. Now for a closer look at some of the prints HT3 has been producing. Ornamental or aesthetic prints in more than one colour but the same material tend to work well. These ones are in PLA. Depending on the distance of the print from the tool mount, you can end up with a little bit of stringing on some prints. The important thing is there's no colour bleed, and the different coloured areas of each print are always clearly defined. So we've seen some multicolour prints, and next we're going to have a look at a multi-material print. This one's printed in PETG. It's tougher to turn. It doesn't make a particularly nice noise when it turns, and this is because the joints and the cubes have fused together slightly because it's the same material. Now on this one, the cubes are printed from PLA and the joints from PETG. Now these two materials will not stick together, and that's exactly what we want for this application, because now the joints and the cubes are properly separate and you end up with a much smoother motion. Now admittedly, printing a better fidget cube isn't exactly groundbreaking, but it does show you that HT3 is capable of printing intricate multi-material models. The machine has only done around 100 hours of printing so far, and so to fully stress test it, it will need to rack up a few thousand. But for now, the mechanism has completed over 5,000 tool changes without an issue, and the machine is churning out really quite impressive prints.
So that was Will's Viva for the HT3 tool changer, the video he submitted for his major project. We're going to get into that in a little bit because there is a lot to talk about. But Will, first guest of the day, how you going? How's it doing?
It's alright. Got a little wet on the way here, but
a little bit damp.
I'm feeling okay.
Does that count as a weather comment? Because
well, it was a heat comment last time, but should we do rain comments this time?
Well, let's just combine it into weather.
Alright,
Yeah.
so we're at 7.
Seven.
So 7,
Seven.
yeah.
It's quite nice and warm in here, so like I've improved
8.
anyway.
8.
No, how did you find the showcase yesterday? Yesterday was obviously the first day.
Really good. There was a lot of people coming past. Some people sort of just come past and go, wow, and why? And some people come past and sort of go, oh wow, this is really cool. I know how this works, and you have a really good conversation with them.
Yeah, I was about to say, did you get a chance to talk to many people that came around?
Yeah, I think sort of 4 or 5, 6 people stopped and we had a really lengthy conversation, and there was probably 10, 15 more who stopped and said hello, basically, so it was good, yeah.
Awesome. Okay, well, tell us more, man, about this gargantuan project.
Yeah, so essentially a tool changer is like a regular 3D printer, except has a special mechanism which allows it to pick up individual tools or extruders, and that makes it sort of like a research platform, really, because you can kind of adapt it to whatever needs you want. So I'd say that's the general overview, yeah.
Oh, okay. And I think, as obviously I've seen your project before in the book and such.
Yeah.
And watching the Viva, just straight away you have the model, and I was instantly like, wow. And now I've seen the model in person as well. How many hours did it take you to build that final prototype?
I built it over the course of probably 2 months. I built the X-Y axis first, just to check that would work, and then sort of test the mechanism on it. But really, I think probably I did 3 weeks of kind of solid 5-hour days of doing it. So, but probably, yeah, it was a lot, but it was okay. Yeah.
You spent that much time modeling? No? Okay.
No.
Oh, right,
No,
okay.
I didn't. I mean, I'm already bitter because Will's project, which is one of the very few physical models that we do have in the show, is not only the biggest model, it's also right next to my
Yeah,
presentation.
I'm sorry
space.
about that.
So if you could just maybe like give me some pity visitors, just kind of shift them across in
I have
my
actually been
direction.
pointing them towards your stand.
That's, you know what? That's
nice.
very appreciated. But yeah, talk to me about the mechanics of the product then.
Sure. So I guess the mechanism is the most unique part. So the motion system is core XY, which means the motors are stationary rather than moving, which is great because then you can move the tool head faster. But yeah, the mechanism is the interesting bit because that's an electromagnet. So basically it means it can hold around 2 kilos, so you could have a pretty hefty tool on there. And it's really quick because it's just sort of snap on, snap off, so it'll go in and pick up a tool and drop it again. So it's pretty good. Yeah.
And what makes this product better than, for example, dual extrusion products that are also on the market?
Sure. So if you were sort of coming along to me and saying, I just want to print with 2 colours or 2 materials, I might tell you to get a dual extruder or an IDEX, purely because they're set up for that, and you can actually print, you can do mirror printing where you'll print both of them at the same time, so it's beneficial for that reason. But if you thought, maybe I want to sort of have 3, 4, 5 colours at some point, even if you don't want them at the beginning, you'd be better to go for a tool changer, because you can just add more tools to the tool dock, basically. It's only limited by the amount of space you have, and the design is scalable, so theoretically you could have one as big as this room and then have sort of 50 tools on it if you really had the parts for that, and made it rigid enough.
Yeah. So, where did the inspiration come from?
So there's actually a couple of existing tool changers. It's a new technology, but the main inspiration was probably the E3D tool changer, because I saw that and I saw a lot of people sort of saying, it's amazing, what an awesome piece of technology, but it's kind of not in my price range, or it's not affordable for me. And so I thought, how can we take that kind of massive hunk of metal, which is perfectly engineered, and basically make it out of printed parts, because then everybody can just sort of start to print the parts and print them as they go along and kind of slowly build it up. So that was kind of the inspiration, and I just thought we need a new, and then from there I realised I need a new type of mechanism, because it wouldn't work if it wasn't perfectly machined, and from there, went with the electromagnet, and that was sort of what drove it.
So if the idea is to, print the parts, I'm guessing you've probably made it open source in a way. And if that is the case, do you have any plans to maybe commercialise it, or kits or something like that? Or?
Sure. So the original idea was just to make it open source, release a kind of a parts list with a few kind of recommended sellers, I guess, and then the whole design of it, so all the CAD. But obviously the issue with that is if people want to build one, they have to actually source the parts themselves and buy them, and then they're going to be paying shipping from something from Germany, something from China, and it gets a bit much. So if somebody did approach me and said, I'd like to make a kit out of it, I think that would be better for everyone, because then they can have you can just buy it from one place and put it together yourself and just print the parts yourself. So yeah, definitely open to it, but I think
open to kits.
It will definitely be open source for sure.
I'd buy a kit.
I'd buy kit. Because, I mean, additive manufacturing is something I'm interested in. It's something that I did my major project on as well. Was it something that you always had a background interest with?
Definitely.
Or a foreground interest with?
Yeah, I think at school we had one. That was going back probably 5 years now, and I was really interested in it, but I had absolutely no idea how it worked. You just see it printing and you think, oh, that's cool. And then I sort of played around with them a little bit on and off through Brunel, and then I had my placement last year, where they had at Luwak, which had a fleet of 3D printers, 6 or 7, all running, all different types of machines, all running different firmwares, and that was where I really sort of learned about it, because there's just so much going on, and they were breaking all the time, due to some people on the team who I won't mention. But yeah, so that was kind of where it grew, and then this year I figured I'd probably do something with 3D printing, because that was where I've got all this newfound knowledge.
That's really cool.
It's an awesome project.
Yeah.
Cheers.
Jealousy aside, I think you've done an awesome job with it.
Thank you.
Can I just ask, as a final question, HT3?
Yeah.
What does that stand for?
I thought you might ask that.
Yeah.
So basically,
following our naming questions.
yeah, there's so many 3D printers now. It's so hard to find a name that isn't taken in some capacity. So my thought process was, okay, let's just do it with letters. So I just went with H for my name,
right.
T for tool changing, and then 3 for 3D printer.
Oh, right, okay.
Not that interesting, unfortunately.
Yeah. There's reasoning behind
logical,
it.
Though.
Yeah.
That one. That's nice. That's a nice linear kind of, yeah.
It's a good one. No,
Anyway.
thank you very much, Will, for joining us and sharing your major project. We will appreciate it. We will be back with another student project in a bit. Hello, we're back with our second student of the day, Peter, and we've also got our second Viva video of the day. So here is Peter's Viva project.
There are an estimated 240,000 people in the UK who currently have edema. Edema is the buildup of fluids in the body causing swelling as a result of the lymphatic system failing. This is common in the lower legs, ankles and feet, but does occur in other parts of the body. Edema is often a side effect of other issues or procedures such as cancer treatment, heart disease or surgical operations. A patient's quality of life is severely impacted by the condition, which can lead to social isolation, anxiety and depression. In the early stages of the disease, patients with lower leg edema are advised to raise their legs to relieve swelling whilst seated. I have collaborated with Royal Brompton Hospital to design a footrest that meets the needs of patients and staff whilst being practical for a hospital environment. Existing models of footrests do not meet several key requirements for patient care, such as providing bilateral support or being able to change the height and angle of the footrest. Patients with edema are at risk of developing pressure ulcers that current footrest models fail to consider. This can lead to the exacerbation of the condition. To be used effectively in hospital environments, footrests should be collapsible so they can be stored away, lightweight, robust and easy to use. This allows staff to quickly and effectively access the footrest for a patient who needs it. Secondary research was carried out into edema, assistive medical devices and existing footrests to gain a broad understanding into the subject. Through conversations with clinical staff, 8 key requirements for a footrest solution were established to ensure that patient care and usability would be at the centre of the design. These key requirements are to provide effective pressure relief, bilateral support, to be able to adjust the angle and height independently, to be lightweight, durable and easy to store while maintaining a low price. With these requirements in mind, the design process began with sketches which developed into a series of iterative sketch models. As the forms of the model developed, the overall dimensions were guided by ergonomic data collected from users. After a lot of testing and refinement, Levata was born. Levata is a bespoke footrest for edema patients. The design incorporates 2 memory foam cushions on top of a flexible rubber hexagonal mesh that flexes underneath the cushions as weight is applied. This ensures excellent pressure relief for patients and allows the cushion to be easily replaced when it wears out. The footrest frame is made from Kebony, an FSC certified timber made from fast growth softwood, which is then treated with natural oils to create an environmentally friendly hardwood. The warm dark colour of the wood is a stark contrast to the brushed aluminium and chrome plated steel often associated with medical assistive devices. Levata incorporates a double ratchet mechanism with a quick release handle for a wide range of positions and effortless adjustment of both the height and angle. When the footrest is fully collapsed, it has a very low profile, allowing it to be stored underneath hospital beds, chairs, or hung against the wall to reduce the amount of floor space taken up. Levata uses a modular design, sustainable materials and ergonomic shapes to provide the best in lower leg edema patient care.
So that was Peter's project, Levata?
Yep.
Am I pronouncing that correctly?
Yeah, that's it.
Okay. While I'm at the name, would you like to talk us through the name and how you came up with the name?
Yes, so the name was derived from a Finnish word, I believe, that's about, it sort of means to support or to elevate.
Okay.
And because this is a leg rest where you're supposed to elevate your lower legs, it sort of made sense to include it. Yeah.
No, I like that one. It's good.
Yeah.
I like it when people just go
A solid
from
name,
different origin.
a nice word,
Yeah.
sounds good, sounds designing.
Exactly,
Yeah,
that's exactly what I was aiming for.
Yeah.
Awesome.
It's great that you managed to work with loads of specialists
Mhm.
on your project from Royal Brompton.
Yeah, that's it.
Yeah. Was there anyone in particular that was extremely helpful, and was there an aspect of your product that you were helped with that you wouldn't have been able to kind of work on without them?
Yeah, so my clinical champion was Ferial from Royal Brompton Hospital, and her expertise is in skincare within the cardiology unit, and that's really where I needed a lot of my support because I didn't know anything about edema and patients with the condition, so she was able to point me very clearly to specific patient needs, but also what staff need on a day-to-day basis when they're caring for patients and providing assistance. Yeah.
That's really cool. Another thing as well is a little bit of a rarity this year is you have actually made a physical model.
Yep.
And what we've inadvertently done is we've put probably certainly the two biggest, but also maybe the two most impressive physical models we've got at the show. Sorry, everyone else. Don't take it with a pinch of salt. Kind of quite close to each other because you're in adjoining rooms. So talk to me about how you made the model.
Yeah, so the model was quite complex to build because a lot of it had to be made from scratch. So the white frame on the top is a large 3D print that was done in the university workshops in 4 sections glued together and then sort of fillered and sanded down so it looks like one continuous piece.
Sure.
And then the body is all made out of kebony, which is sort of an artificial wood product where they take a fast growth pine, modify it with natural oils, then it becomes incredibly hard and dense. So I managed to make that in a home workshop we built in our student house that our landlord doesn't know about yet.
He knows now.
With this broadcast he will. Yeah, and that was really beneficial because me and my friends were worried that we wouldn't have access to university workshops, which turned out to be the case. And we were able to do a huge amount of making ourselves without having to rely on the university too much.
Where did you first encounter kebony? And is there like a specific property that you really want to use kebony for that?
Yeah, so I encountered it in our second year. There was a competition they were running that we were able to apply to, and I was really interested in their properties because I've done a fair bit of furniture design in my own time, and downside of modern furniture design is that hardwoods are sort of a depleting resource at the moment because they take so long to regrow, even in managed conditions, whereas kebony takes a fast growth wood and turns it into the properties of a hardwood. So environmentally it's got some fantastic benefits, but it's also only used in architectural cladding at the moment, so the opportunity to take a material, use it in a new context was really exciting, and also showed that there's more opportunities for the same technology.
Yeah. Oh, okay.
Can I ask what you did for the second year kebony project?
Yeah, I did design a table, but my concept was like trying to change their process slightly of could they steam bend timber into interesting shapes and then modify it with their process.
Sure.
So you'd have sort of more twists and curves going on in the furniture itself, then modify and it become really hard and dense. And it could last a really long time. Yeah.
Awesome. Really cool.
Yeah.
It's a really cool project, Pete. And again, really impressive, really large model.
Thank you so much for coming on. We really appreciate you sharing your major project with everybody. We'll be back with another student in a minute. We're back with Dani and her major project. It's the 4th member of the MIB team we've had on now.
We're working our way through.
We're working our way through. Good, yeah. Dani's got a Viva presentation video, so we're going to play that now.
Rosacea. What is it? There's a lot of information out there. It's overwhelming, really. Doctors find it difficult to diagnose, yet 1 in 10 people in the UK are thought to suffer from it. And these people suffer in silence. They face confusion and are often stigmatised due to the visual symptoms of the condition: redness and flushing, pimples and pustules, rhinophema and ocular symptoms. The solution is Rosette, a product service system which aids in the self-management of rosacea at any stage of the condition. The user-friendly interface helps users to feel more comfortable when coming to terms with and understanding their condition. Simple visuals and illustrations are there to aid usability and provide a link to the real world. Save meals and products to your cupboard to make logging daily entries a quick and easy process to take the frustration out of logging every detail of your life. Suffering from a flare-up in your condition can be hard, but with Rosette, the thinking is done for you. Rosette can find patterns in your routine and match them with your flare-ups to discover any triggers you didn't know about before. It's rosacea management with a mindful approach. Each case of rosacea is different. Some people's flare-ups are caused by food, some are caused by cosmetics, emotions, and even the weather. Being safe from the sun is something most people don't consider, but it is the most common rosacea trigger. When the skin barrier is damaged by the sun, rosacea is more likely to flare. In addition to this, many common rosacea medications, such as doxycycline and tretinoin, can temporarily weaken the skin barrier, unaware to the person taking the medication. This makes the skin highly sensitive and at higher risk of sun damage. This is why Rosette comes with the UV pod. This pod will measure the UV levels wherever you are for accurate data. The user can also set a daily UV limit to limit exposure to harmful UV rays. UV sensors have historically been single-use, which are thrown away after a day's use. The pod can be worn again and again, using the magnetic clip to secure it to anything, be it a bag or a jumper, as long as it's exposed to light. The longer Rosette is used for, the more accurate it will become. The interface supports the user with phrasing which supports, not alienates the user. Over time, the user can review their progress in the My Skin tab to see if there are any changes in their condition severity, flare frequency, or mood change. If a user was to input a low or stressed mood for a prolonged period of time, they would get tips on their homepage for custom exercises to manage stress, without having to download any additional software. Over the design process of Rosette, heuristic design principles have been kept in mind. These have helped to inform the design and create a better overall user experience. Clear and understandable error screens have been created in the event of a user making a mistake within the app. A consistent colour scheme and style has been generated for usability and brand awareness. Accessibility has been strongly considered with features such as dark mode as well as a dedicated help centre. These small design considerations work together to ensure a strong positive user experience with a mindful touch. The process was built up from initial sketches to wireframes to a final prototype. Rosette, created by rosacea sufferers for rosacea sufferers.
So that was Dani's project, Rosette, and it's meant to tackle rosacea.
Yes.
I find it really interesting that you've chosen to focus on an issue that you've experienced firsthand. What kind of struggles have you experienced with rosacea in your personal life?
Well, kind of over my placement year last year, I ended up, I went on holiday and I got a bit of sunburn on my face, and then over time it kind of snowballed into kind of serious skin damage. I ended up going to the GP back and forth every single week, maybe even twice a week. I was having to get emergency appointments and they just didn't really know what was wrong with me, and I was put on steroids, antibiotics. I had like 50 different moisturisers, and it wasn't getting better at all. And I ended up having to see dermatologists as well, and eventually I kind of learnt about rosacea. And kind of when you're at first diagnosed, there's just so much information out there and it's so overwhelming. There's just too much on. There's so many different elements to the condition that's different from, say, eczema or psoriasis, which are more well known in kind of skincare. Like a lot of kids say have eczema, but you don't really hear about rosacea. But it is common. It's 1 in 10 people have it, but it's so underdiagnosed. But it's just, as kind of a brief intro, it's just generally you get real bad redness, flushing. You can get acne. Your eyes can swell up, and it's just extremely hot, painful, and prickly. And with it being on your face, you can't hide it. So it's that sort of thing where I was getting the tube to work every day, and I could just feel the people kind of staring at me, and it's just not nice. And it was just, I wanted to help other people who were going through the same thing as me, and that's why I wanted to do it as my major project.
So this is an app that, I'm guessing as you were designing it, you could see yourself using it.
Yeah. Well, it was nice to put myself in kind of the user's shoes in that way, but I did also kind of have to keep in mind that generally with rosacea, it happens to people in the mid kind of 30s and 40s, because it kind of comes with years of kind of exposure to the sun. Whereas for me, it was that extreme one-time thing that kind of triggered it. Even at the show, I've been struggling a bit because it's so hot in here.
9, yeah. If we do it by people, it's 8.
Okay,
I do it by person, so we're at 8.
We're talking about the heat.
We're talking about weather.
Weather in general.
And you already mentioned the weather.
Yeah.
No, it has been a struggle at the show. We're used to it now, I think, though.
Yeah.
You mentioned various kind of elements to the condition. How did you go about taking those elements and translating them into the framework of an app?
Well, I kind of had to start with kind of creating a map. With UX, everything kind of feeds into different areas, so you have to think, how is one element going to relate to the other? And there are a lot of concrete things that happen to different people with rosacea. Kind of every case is different, but I wanted something that kind of encompassed every single area of the condition. So with the product that I had made, that was to tackle sun damage and kind of controlling your UV exposure, whereas the app kind of focused on your food intake and what cosmetics you use on your skin, and kind of taking control of your emotions. And there was kind of a small kind of mindfulness aspect to it as well. So it was kind of important for me to get as much in as possible, but still kind of keeping the clean, simple interface that's kind of, it's not overwhelming to use, and it's just kind of a calming experience for the user.
And that calm probably comes through with the colour scheme as well.
Yeah.
And, you've kind of strayed away from the reds, gone for more blue.
Yeah, well, I originally wanted to use red as my main colour. With the etymology of the word rosacea, it comes, I believe it comes from the French rose-coloured, and obviously kind of the red, I wanted to kind of symbolise that sort of, it would just kind of relate more to the condition, and it would be more specific. But obviously red is a powerful colour. So when I was kind of doing my first mock-ups, I was like, this needs balancing out. And obviously with red and kind of pinkish hues as well, like I wanted it to be a kind of unisex app, because it is in men and women. It is, I think, 80% women, but men can get it, and when they do, it is a lot worse in terms of severity. So I wanted something that could be for everyone, and that's kind of why I settled on kind of neutral palette with some kind of bright tones.
It's very interesting. No, thank you very much, Dani, for coming on and sharing your major project with us. Really appreciate it. We will be back with another student project in a second. We're back with George and his project Yum, but first we're going to be playing George's Viva presentation video. Here it is.
Yum is a device that aims to improve medication adherence in children by adding flavouring to the medication. The device comes in a carrying case which can hold 7 days worth of medication as well as flavouring. The medication as well as the flavouring pods are placed into the device. These flavouring pods come in a wide range of flavours that are ordered from the app. These are then delivered to the user's home address. Limited edition flavours will be released throughout the year to keep the child interested in the product. In order to use the device, both the medication and flavouring pods are placed into the device and the lid is attached. When the lid is attached, the piercing tools on the lid pierce the top of both the pods, allowing the liquids to escape and mix within the mouthpiece, allowing the child to suck the medication and the flavouring out. To unlock the lid from the device, the user has to squeeze the front and back of the lid, expanding the size and releasing the lugs. Here you can see the pods were pierced successfully. When the device is purchased, the child is able to choose the colour of the body itself, the lid of the device, as well as the grips and the carrying case, to help remove any stigma and intimidation by the product. An accompanying app works with the product in which the parent is able to monitor the medication. Here they are able to record every time the child takes medication, the flavouring that is used, the date, time, and is able to rate it. There is also the option to record other medications such as cough medicine or paracetamol. This is all sent to the doctor as requested. They are able to monitor their stock of the pods they have, both the medication and the flavouring, and from this app they are also able to place more orders. If the user clicks on one of these flavourings, they can see the notes and the rating about that medication from their past experiences. There is also a child mode to make ordering the flavouring more fun for the child, in which they spin the wheel and the flavour is selected.
The user's medication history is also visible from this app, being able to backdate every day which medication was taken at what time and the ability to add notes. There is also a community section to the app in which parents are able to communicate and share tips and ideas and support each other. This aids in future product development and helping users that are new. There is also a support feature within the app in which the user is able to speak to an advisor that is available 24/7 for any questions or concerns. They're also able to access frequently asked questions in this section, as well as being able to order any replacement parts that are required as parts wear out.
Absolutely love your project, George. Absolutely love your model as well. I was over at your stand the other day and we saw your models. How many models did it take for you to get to your final one?
I think I went through about 40 prototypes. It was just printing. But yeah, no, it helped me, all the prototypes.
Yeah. Alright, okay. So what was the most interesting fact that you found from like your initial research around children, medicine, that kind of stuff?
It was 3/4 of children don't like the taste of medication.
Okay.
So that's what led on to the product.
Wow. 3/4.
That's pretty.
I mean, pretty large.
I mean, I used to love Calpol
Oh, I like Calpol. Yeah.
and stuff like that.
Yeah.
But, yeah. It's really, it's a really cool project. I think there's the whole idea of medication management is something that I think needs addressing kind of just very widely. Was that something that you were looking into right from the start?
Yes, I've observed family members struggling to get their children to take medication because they didn't understand why it was needed, and they don't understand, and it doesn't taste nice. It's a struggle to get them to take it.
Yeah.
So that led to the children fighting the parents, refusing to take it, and then that can affect the quality of the treatment.
Yeah. And obviously I know that you've got an app that goes with your
Yes.
product. Can you explain a little bit how they two integrate together? And how they work? Yeah.
So they're two separate things. The app will notify the parent when it's time to give the child the medication, allow them to record any other medication that's taken, so then if the doctors need to see the records, it's all there for them to see.
Yeah. All right. Okay. What kind of considerations were taken, with the actual form of the product, specifically to cater to children and that kind of stuff?
It was making sure that the size of the product was fitting the child's hand.
Okay.
Obviously, due to COVID, I couldn't actually find any children. So I 3D printed some children's hands to size. I was just getting creepier, but to make sure that it fit in the size of the hand.
Yeah.
That's cool. And just very quickly, were there any considerations made for medications that are potentially unstable outside of their original packaging at all?
They are considerations that are going to be taken in the future. There is some companies that do a very similar flavouring, but that has to be added to the whole bottle of medication. So obviously if you've got a medication that's been flavoured and the child doesn't like it, you're back at square one.
Sure.
Yeah. So you just reminded me actually, because you just said you 3D printed a bunch of babies' hands.
Yeah.
I was shown an image on someone's phone.
Strange
You tried to did you try to simulate a baby at one point, or render a baby?
Yeah, I was.
A full-size baby. Okay.
Oh, it's got weirder.
Yeah.
No, that was trying to get the right size so the hands were to scale.
Right.
So
Okay.
it was,
you modelled the entire baby.
no, just the hand.
Oh, just
Just
the
that,
hand.
just that. That
Just
makes
that.
sense.
That's fine. That's all right.
Any more, that'd be weird.
Yeah.
But no.
Yeah.
Your project was obviously quite recently featured on the Made in Brunel Instagram. I must say you've got some very nice visuals. Some would say they're rather yum.
Ooh.
Yum. I'm so sorry.
On that note, can you tell us a bit more about the name of the product and why it's called Yum with two M's?
It was a 2 a.m. thought, but it was because it makes the medication yummy and tastes nice. So that was nothing really exciting. It just that's where it came
it's simple.
from.
It literally does what it says
Yeah.
on the tin.
It's a bit of a, is it onomatopoeia in there? That sounds like what it is?
Yes.
Yes.
There
we
you
go. Big words now.
I was thinking palindrome, but
Alright,
it's not.
it's not a palindrome.
Not a palindrome.
No, it's not a palindrome.
That would be muy.
Or yummy. Yummy. It'd be yummy with a U and a Y at the end.
Whatever. That's
Yeah, anyway. Thank you very much, George, for coming on and
Thank you.
sharing your product. Really appreciate it. We'll be back in a couple of minutes with another student. We're back with Isabel, and we're going to kick off again with another Viva video. So here is Isabel's medical Viva video.
An investigation into how to train clinical staff to insert central venous catheters into neonates. Each year, 100,000 babies are admitted to neonatal units across the UK. Many of these babies need intravenous fluids and medication which can only be administered through a central venous catheter. Clinicians perform a procedure to insert a CVC via the femoral, internal jugular or subclavian vein. Currently, the British Association of Perinatal Medicine acknowledges that there are no validated training packages available for CVC insertion and are looking into how to reduce harm after several associated fatalities. The solution: a neonatal CVC training simulator that teaches clinical staff how to safely insert a CVC into a neonate using an ultrasound-guided technique. The neonatal CVC simulator provides clinicians with a sensory and specifically haptic training experience that closely replicates the real-life procedure. This project is in collaboration with Guy's and St Thomas's Hospital. This collaboration has provided the opportunity to connect with clinical stakeholders and has allowed for a human-centred design methodology to be used throughout the project. This approach has meant that there has been constant collaboration with clinical staff. Thorough background research was carried out using both primary and secondary research techniques. From interviewing clinicians, I was able to gain an insight into the current training procedures at Guy's and St Thomas's Hospital. To become proficient at inserting a CVC into a neonate can take many years. It starts with learning the anatomy and the theoretical processes. Next, they are required to become competent with ultrasound. Now they will begin by observing senior staff carrying out the procedure and slowly begin to assist, starting with the simpler aspects of insertion. From this insight, it is clear to see how the training is insufficient considering this is a critical procedure on very frail patients. Clinical staff reported that CVC insertion is one of the most challenging procedures they are required to perform. This is shocking as nearly every child in Guy's and St Thomas's neonatal ward has a CVC line. Complication rates are reported to be between 4 and 22%. Here you can see the 4 key requirements that the users specified: looking realistic, feeling realistic, ultrasound compatibility, and to be robust. 10 different tissue mimicking materials were developed and evaluated. From the evaluation, 3 of these appeared to be feasible from the ultrasound images, samples A, B and E. These samples were then evaluated with repeated needle insertions and tested to find their Young's modulus to determine how robust they were. It was clear that the PVAC was the most appropriate. Bone and vessel mimicking materials were then embedded in the PVAC and sent to the hospital for evaluation. The design was based on CT and MRI scans of neonates. These scans were segmented and converted into a 3D model. When the 2D data is converted into 3D, extensive post-processing needs to take place to create an anatomically correct CAD model. These models are the basis of the final design. Here you can see the final prototype assembled and ready for use. There are 5 proposed training modules: learning the anatomy, practicing ultrasound, the insertion technique, possible complications, and aftercare and removal. The final design is composed of 3 main components. The insert is where the CVC is inserted and is the most important aspect of the simulator. The shell is not essential for the insertion procedure, but aids in making the simulation more realistic. The pump system is designed to create the simulated blood flow through the training simulator. The chosen blood mimicking material is water. For the arterial blood flow, a peristaltic pump has been used to create a pulsatile blood flow. For the venous blood, a simple water pump has been used to create a uniform flow. The simulator is very easy to assemble. The insert connects into the outer shell using magnets. This means that it is easy to remove the insert after use and store it in water to preserve the tissue mimicking materials from degrading. The pump system connects to the simulator using silicone tubes and nylon connectors. In the following video you can see the final prototype in use at Guy's and St Thomas's theatres. Here you can see a consultant anaesthetist using an ultrasound machine to identify the key anatomy and insert a needle. You can clearly see the vessels on the ultrasound and the needle tip as it is inserted into the vein. Overall, the feedback was excellent and is definitely an improvement on the current training procedures.
So that was Isabel's video. I think it's a really cool project.
Oh, thank you.
How did you test your project to simulate a child's, in an ultrasound?
I developed lots and lots of different ultrasound compatible tissue mimicking materials and posted them to the hospital, got them to ultrasound them, send me back the images. I also got some needles and was testing the resistance as you inserted and pulled out the needles to see how it felt in comparison to a live child.
Ah, okay.
Yeah.
Wow. And that model's really cool and really well detailed.
Thank you.
So was that with the help of someone at the hospital?
So I was given the CT and MRI scans of a child, and then I did a process called segmentation. So each layer of the scan, I highlighted the key anatomical features that I wanted in my model, and then converted it into a 3D model, which I was then able to 3D print and use the models to create the anatomical features inside, and then coated it with the ultrasound tissue mimicking material, so when you scanned the model you could see all the internal anatomical features.
Oh,
That's really cool.
so that's basically a real...
Yeah, this is a real child.
That's a real child.
Well,
Scan of him.
it's as close as you're going to get. One up from George.
He was just modelling hands.
Brutal.
So
Yeah, no, it's really, really cool project, a very striking project as well, because it's right just next door to us in a medical room, and it's kind of right in front of the door.
Yeah.
So they put our own wall, you're like, whoa, okay, that's cool.
Thank you.
But the other day we had Alice on talking about like a surgical robot,
Yeah.
and hers project was kind of focused on more generic use. This project seems to be more of a kind of specific use with like haptic feedback, and I'm just wondering where that kind of interest stems from.
So I did my placement working in the medical physics department. One of the clinicians, Richard Goodwin, came to the department and raised some safety concerns about clinicians inserting the CVC into neonates because unfortunately, as they insert it, as the children are very small, if something small goes wrong, it can cause fatal injuries. So they were looking into how to improve the safety of the training. So I thought that was really interesting and thought I'd love to take that on for my project. Yeah.
That's pretty interesting. Your model is very well detailed. I'm guessing there was obviously a lot of testing, a lot of prototyping that went into that. Was there any staff from Brunel or St Thomas's that was really helpful with that?
Yeah, definitely. Yeah. Paul Joss was a big help throughout, of course, and I had some of the technicians and mechanical engineers from the hospital who helped, and got some feedback from some of the scientists as well from the hospital. So yeah, it was really great, really good collaboration.
Awesome. And have you had a chance for anyone from the hospitals to come around yet and see
yes.
it all physically on the stand? You have?
Yes,
and
yes.
What did they think of it?
Oh, they were really pleased with it. It was
Yeah.
really good feedback. So yeah, no, yesterday I had a nice group of the commercial department, some of the scientists, mechanical engineers come in, so it was really lovely, and I think they enjoyed looking at some of the other medical projects as well. So
Awesome,
really
yeah.
exciting.
Yeah. So is this the kind of thing that it's going to be taken on?
Yeah, right. I hope so.
Okay.
We're talking about the process of
Congratulations.
commercialisation
Well
and the steps forward. So fingers crossed.
Yeah, it should be good. No, thank you very much, Isabel, for coming on and sharing your project with us.
Thank
really
you.
Interesting. Thank you very much. We'll be back with another student in a little bit.
Thank you for joining back with us with MIB TV on this increasingly damp Friday morning. We're joined now by Jayda, who's got her project in front of her. Jayda, what is your project, please?
So this is Needle Doc, and the brief was kind of to create a sharp spin or a device that helped with the managing of equipment for type 1 diabetics. And basically it was a response to the traditional sharp spins that are already available to diabetics. And in 2008, there was a report that was done by the NHS, and it said that over 100,000 medical staff had experienced needle stick injuries, but that if every single instance was reported, that then a figure could be twice that value. So medical staff are trained to deal with sharps. So imagine a newly diagnosed diabetic trying to handle sharps and not really having the same amount of training. So there are more needle stick injuries with patients, especially at home. And traditional sharp spins are designed and manufactured for use in hospitals. So when you put that in your house, it's not the most appropriate thing. Sometimes they're really big, so you can't store them properly. Sometimes the opening at the top is too small, so you can't fit all of your equipment in. And sometimes, well, they could be too small or they could be too big. And then if they're too big, if you have children or pets or visitors and stuff like that, you kind of want to make sure you put in it out of sight. So this sharps bin is kind of a solution to that, and it's specifically designed so that this aperture at the top satisfies the geometry of most popular diabetic equipment, such as insulin pen needles, Libras, lancets, things like that. And then an additional opening, which can only be opened by hands of a certain size, so larger adults and stuff, in case you want to put larger equipment in, such as insulin pumps, infusion sets, something like that. And then this whole section expands, and you can lift it up. It kind of works on like a telescopic mechanism, and that expands the capacity of the container. So it is easily stored, and it kind of, you can use it to specify whatever needs you have. And then this is a travel device. So it's like a portable sharps bin, and it's reusable. So if you're traveling on the go, going to work, going to school, something like that, you can store your sharps in the flexible compartment underneath, and then throughout the day, as you're using your sharps, you transfer them from this section to this section of the device. And this aperture here kind of mimics this one as well, so it takes specifically diabetic equipment. And then at the end of the day, when it's full or whatever, you can unscrew this bit and then put the sharps in this, because it fits perfectly. So,
by design.
And then reuse the device all over again.
Yeah.
But yeah.
It's awesome. It's a really, really well executed project.
Thanks.
It seems from like what we've just heard about it that it's quite heavily rooted in the making it as easy as possible for the user, the kind of the human elements to
100%.
it. So what kind of considerations were there from that perspective?
So a lot of diabetics found that the sharps bin that they currently have, they don't always get the same one, so it's not consistent. It depends on where you live, who your pharmacist is, what GP you're having at the time, and kind of who's collecting it and who's servicing your diabetic equipment. So sometimes they don't have a sharps bin that's big enough, sometimes the opening at the top is too small, so you either use as much of the sharps bin as possible, but then because sharps bins are sent to incineration, it's not completely full, so it's kind of a waste of all that plastic. So definitely I wanted to create something that was specified to those diabetics. There are 400,000 diabetics in the UK alone, and it's not, type 1 diabetes is not a condition that you can prevent, and it's currently not a condition that you can cure. So you have to have it throughout the whole of your life, and you have to be able to manage and control it. So just this simple solution kind of makes that day-to-day quality of life a little bit more comfortable. Yeah.
Consistency is key, effectively, making sure
that
you're maintaining the same points of reference. I was just wondering actually about the you mentioned it briefly there in the incineration. Does that follow the same process with needle dock?
Yeah, 100%. It's that with the at-home sharps bin, this would kind of take that same route. It could be prescribed by your pharmacist, or you could buy it online as well. I definitely wanted to create a solution that could be manufactured quickly and cheap, because current sharps bins are extremely cheap. So to be able to kind of compete with that was really hard for me. But in the end, I am creating a specified solution that people are going to want. And then with the travel device, you don't have to incinerate it. You can reuse that. A lot of diabetics, when they're going to work and stuff, sometimes they keep their used sharps in like a Ziploc bag, or they just have them loose in their bag, which is quite dangerous, especially if you end up getting pricked by your needles. So this device, you can fit it into your rucksack, your purse, whenever, and it is reusable every single day. So yeah.
You said at the start that you got a brief. Is this a collaborative project then?
Yeah, this is a collaborative project with the company NeedleDoc.
Okay.
And they did help me throughout a lot of the research and development phase. I spoke to a lot of diabetics as well, and was able to get a lot of statistics from that. And the solution was that they chose to kind of take forward this aperture design, but I really wanted it to be a successful product. In the case where I really wanted the user to feel like, okay, this has everything, it has this, it has that, everything that I could possibly need, so I need to buy it. So that's why the further development was done and the travel device was made as well.
And you've obviously touched on a lot of uses for the product, and you're very knowledgeable about it. Is this something that you were passionate about before, or something that you came into after learning about the brief?
I definitely wanted to do medical design. That was something that was really strong for me. I don't have diabetes. I don't know anybody that has type 1 diabetes personally. But I almost feel like an honorary member of the community after doing this project. I've spoken to so many diabetics, it's actually ridiculous. I thought I knew enough, and then speaking to someone, I'm like, oh wow, like I really don't know anything at all. And it was like kind of that same process over and over and over again, and learning people's stories and getting to really listen to them. And they really want to be heard, but because they get so much equipment for free, it's kind of like a guilty struggle. You don't want to ask for more because diabetes is so expensive to control and manage and things like that. So just listening to their stories and their concerns and their anxieties was just like amazing, and I just really wanted to help them.
Awesome. Jayda, you're a product design engineering student, aren't you? So
Yeah.
we've spoken a little bit about the human factors, but I'm sure your product is chock full of kind of little mechanisms and bits and pieces that show off the engineering side.
Technical aspect.
Definitely. The aperture at the top has a tolerance of 1.3, so you can fit needles in quite comfortably. This kind of works on like a soft hinge as well. This is a sliding mechanism, so you can have both temporary and permanent closure of the container, so that obviously if you don't, insulin has a smell. It's not a great smell. So people don't want their sharp spin to always kind of be open. So there is a temporary closure that closes the sharp spin, and then a permanent closure that way you can't open it back up and it should be sent for incineration. And then obviously the expandable part of the sharp spin works on a telescopic mechanism and almost like a ratchet, where when you pull it up, you can't push it back down. It's permanently there, so that's great. And then for this, the travel device, it works with a rotating lid, almost like a salt shaker, where you rotate it to open, rotate it to close. So it kind of works on friction as well. And yeah.
Well, a really holistic product, and it's great to see that you've had such support with the company from it as well.
Yeah, definitely.
Yeah. No, thank you so much for coming on and showing your project, everybody. Really appreciate it.
Thank you.
We'll be back in a minute with another project. We're back with another major project and a familiar face. It's Joe, the director. So we're at MIB member number 5 now.
MIB member number 5.
Yes, that number is slowly creeping up. Joe's got a Viva presentation video, so we're going to show that now.
Every minute in the UK, 2,000 prescription items are dispensed. Half of us have at least one regular prescription, and a quarter have more than 3. Yet, it is estimated that half of all medication is taken incorrectly. Medical non-adherence is a largely unknown issue. However, it accounts for costs of nearly $300 billion and hundreds of thousands of preventable deaths globally every year. Patients with chronic conditions are often the group that have the most complex medical regimes and suffer from worse adherence rates because of this. Despite this, management of medication is a task that almost always ends up in the hands of patients, yet very few tools and resources are available to help users keep control of their medical regime. Docet is a smart medication management system to assist users adhere to increasingly complex medical regimes. This system helps to automate the process and make users' lives easier by aiding in 3 key problem areas defined through primary research. Storage, assisting users with their need to organise their medication to ensure it is easily identifiable and to increase ease of access, especially when travelling. Monitoring, providing the tools to allow users to keep on top of their medication, including assistance with prescription collection, scheduling and tracking. Education, increasing access to information around medications in a way that is easy for users to understand. There are 2 key elements of the final solution, a product and application. The product is available in 2 variants, the Docet and the Docet XL. The Docet is perfect for everyday use, holding up to a week's worth of medication. This product is designed to be on the user's person and is easily stored inside pockets. The Docet XL is designed to be used for larger form factor medications such as inhalers, eye drops and injections, or to be used for longer trips away from home where more storage space is required. Both products follow a similar form with the same organic shape, and both feature interchangeable trays that can tailor the product for each user's personal needs, and both feature tools to assist users administer their medication, in this case a tool where users can easily split their tablet medication into evenly sized pieces. The application tracks the user's conditions and recommends medical schedule changes with the help of AI. Users can effortlessly log a dose taken with NFC integration, plan their medication schedule for trips away, and access learning materials focusing on their condition and tips to increase adherence. The application homepage features all of the user's need-to-know information. A notification tab hosts a weekly overview of the user's adherence alongside notifications regarding changes with their medication, such as medication running low or the application recommending changes to the user's schedule based on their adherence patterns. The homepage also features all of the user's upcoming medication and shows the last medication they took to ensure they keep on track. The navigation bar is found at the bottom of every screen and ensures that users know where they are within the app at all times. The larger blue action button on the navigation bar can be used to access the top-level functionality of the app. Logging a medication is as simple as tapping your phone onto the Docet case, with the integrated NFC module logging the time and informing the product's onboard computer and the application. Medication can also be manually logged using the action button and selecting the medication and time that it was taken. Logging a side effect is done in a similar way. Simply tag the side effects you are suffering from and click confirm. These are stored in your medical history and AI can help identify potential triggers with the medication you are taking. To plan your medication for a trip away, you can select the dates of the trip and the application calculates how much medication is needed and whether you have enough or need a refill before you go. The medication cabinet keeps track of all the medication the user takes. Here, they can view their schedule for any given day or see their archived medication. Adding a new medication can be done manually or automatically by scanning the medication packaging or barcode. Setting up the medication adds it to your medicine cabinet. Each medication also has an individual page where you can view the key information, add your own notes, and see the key things to avoid. Here, you can also order a refill to your prescription when you are running low. The Insights page keeps track of users' adherence, giving the user a score based on how successfully they are following their medical regime. Providing the user with one overall score rather than an unrealistically large set of goals gives them more incentive to improve. They can also look back on their medical history, seeing what medications and side effects were logged on a specific date. The Profile section allows the user to manage their account info, clear their data, or even delete their account. The user can also see the status of their products and view the medication inside each one. When working together, the Docet case and application provide a holistic approach to the issue of non-adherence. The solution takes advantage of available technologies and utilises them to create an innovative tool to assist users with their self-management.
So that was Joe's Viva presentation video. Joe, in your video you had an animation of your trays. You spoke quite a lot about the trays. I think they're really cool. How did you go about specifically designing the trays?
So the trays were obviously quite a big part of the design itself. Obviously with medications, so many people have different types. Although the vast majority kind of use pills and tablets, it's obviously not the only kind. So it's really important to make sure it's the most accessible product as possible. So the different trays are there mainly to offer kind of different sizes in the product. So the large and the small version both have trays with different amounts of compartments. So they can either be split up into kind of 4, more or less, depending on how many kinds of medication you have. And as well, obviously, there's a tool in this tray which helps you split the medication. So the idea was if the project was to be taken forward, different trays would be designed so more tools could be made, obviously making it then more accessible and inclusive to different kinds of conditions.
No, it's quite cool. And like the form of your product as well, you touched on it quite a lot, and as an industrial designer, I'm guessing it's something you focus on quite a lot. So could you talk us a little bit through the form of the product? And
yes,
so different sizes as well?
Yes, there is. So the form of the product is something I really spent a lot of time on this year. So there's 2 versions, a small and a large, mainly for different use cases. So the small version for kind of everyday use, taking medication into the office, into the workplace, around with you, perhaps you're going on a day out.
Yeah.
And then there's the larger version for if you've got larger form factor medication, so inhalers, creams, things like that. And also if you're going away for a longer period of time, so if you're going away for 2 weeks on a holiday, you can take the larger amount of medication with you. And the form's something, I spent a lot of time on. At the beginning, it was a lot of sketching, kind of ideating, creating completely different kind of forms. And then when I settled on this kind of look, a lot of foam modelling. So really trying out different kinds of shapes, how it fit in the hand, things like that. Because obviously that's so important for a handheld product, and especially how it fit in pockets and things like that. Because that's obviously where it's going to be stored for most of its life. So this was all surface modelled in SolidWorks, and that went through a lot of iterations as
Ooh,
well.
Poor man.
Yeah, that was a tough one, but it's really enjoyable actually. It was useful to kind of advance that skill, because it's obviously something that's not that easy to do.
Yeah.
But yeah, then 3D printing a lot of those forms to kind of see how they felt, and slowly kind of finding the right form from that.
Awesome, yeah. It's a seemingly very simple little box, really. It's a medication management, but you've packed this thing full of tech to make the user experience element of it as seamless as possible.
Yeah, so the real key of the product was, and its kind of unique selling point, is that it just takes as many tasks away from the user as possible. So there are obviously other products on the market, medication storage devices, there are apps to help you remember your medication, but the problem is none really work together, and none offer an automation to so many of the things you have to do. With apps, you still have to enter all of your medication yourself. With boxes, they don't tell you when you need to take your medication, they don't help you organise or prepare your medication to take it. So the idea was with this, just creating those little extra features that can really help the user simplify their process and make it a lot easier and nicer to use.
So you use stuff like near-field contact and things like that?
Yeah, so there's
communication, contact.
An NFC reader in the product there. So the idea is when you take a medication, instead of having to open your phone up, go onto the app, and actually find the medication and log that it's been taken, set the time and things like that, all you simply have to do is tap your phone against the product, and it knows that, okay, the AI knows that, okay, you've got a dose scheduled for this time, this is what you've most likely taken, there we go, we'll add that as logged. And then you can obviously correct that if it has made a mistake later on. Obviously, through machine learning, it will get more intelligent over time as well.
Yeah. All right, really cool.
A really slick solution.
Yeah. No, thank you very much, Joe, for coming on and sharing
very
your
much.
project. We appreciate it. And yeah, we'll be back in a bit with another student project. We're back, and we've got Juliette on. We've got Juliette's Viva presentation video, so here it is.
In the next 2 decades, astronaut missions will expand to deeper space, taking us to Mars. The health of astronauts need to be maintained throughout their missions so that they can stay comfortable and productive within the extreme and particular environmental conditions of space. In order to manage any troubles, astronauts will have access to a medical kit. MedSpace offers a new solution for medical kits, built and designed with space exploration class missions in mind.
T-minus 10, 9, 8, 7, 6, 5, 3, 2.
Taking a look at the bottle in closer detail, we have a locking mechanism. The lock is designed to withstand vibration, but can still be easily rotated and removed to gain access to the medication inside the capsule. This is the bellow. This can hold a large amount of medication. A paper prototype is used to show its functionality. The mechanism allows the user to push the medication up into the capsule. Due to the microgravity environment in space, attachment methods are needed to ensure astronauts have full control over the product. Velcro is commonly used in space. We can find it on the walls of the spacecraft and even on the astronauts' clothes. Here are some space shots. Now we will look at the medicine dispenser. This has been designed for everyday use and is personalised to each crew member. A sliding door can be opened and closed to get access to the medication. At the back there is a strap and a space for the label. On the top are 2 rubber grips so that the product can be stacked easily on earth during the packing process. The wheel located on the side is used to move the medication packets inside the dispenser. The wheel can only be moved in one direction to ensure the empty packets are not displayed to the astronauts. The lid is removed to take a closer look inside. When inserting the reel of medication, the end of the reel is pulled and inserted inside this slot. When the reel is rotated, a new medication is revealed when the sliding door is opened. Here is a mock-up of a reel of packets. In reality, this would be lots of medications. However, for demonstration purposes, this reel can be rolled up to create a much smaller footprint. The reel of packets inside the device are slotted into this section to ensure the medicine can come out of the opening. Here are some blister packs. The examples here have a lot of wasted space, unlike the MedSpace packets.
So that was Juliette's project MedSpace, and I suppose the first question, the primary question that I want to ask is, why Mars?
So the reason why I chose to go to Mars was because NASA is actually aiming to go in 2024. Mm-hmm. So if you think about it, that's pretty soon. And so at the moment, there is a medical kit for the International Space Station, and it's not been developed in mind to go to places like Mars. So that's a really vital part of like space development and testing that needs to happen by 2024 to ensure that the health of astronauts are going to be okay for a mission which to Mars will take about 6 to 8 months.
Yeah. And what kind of testing did you do with your project then to kind of check that it would work? You know?
I did do something quite interesting, because obviously it's quite hard to test for a project which is in space because we're on Earth. And so I actually tried an experiment in water, because I thought that maybe, because you know there's microgravity in space and using water might work out. And I chopped up some carrots and made them medicines in this example. And I used my prototype, and it didn't work quite to plan, but it did give me a good enough idea to see how like unexpected the movement of the medications were within this test.
So what can you say specifically about the considerations you made for microgravity climates?
So there's 2 devices in the MedSpace kit, and both of them have dispensing mechanisms to ensure that you are able to get 1 pill out at a time. Currently, the International Space Station kit, they're all in like, the medicines are removed from the original packaging and placed into plastic bags. And obviously you can imagine when you're opening a plastic bag in microgravity, all of them are going to fly out. So my one makes sure that you can get 1 at a time without having to worry about all of them flying out.
Yeah, awesome. It's a really, I'm desperately trying to come up with like a one small step for man pun, but
well, actually,
struggling.
In my report, I actually did say, Houston, we have a project.
Hey. Oh, that's so much better than anything I could come up with on the fly.
That's good.
Yeah.
Awesome.
Yeah.
And actually, we had an award ceremony last night for the Co-Innovate and Santander Awards, and Juliette, I believe you came second, was it?
I did. Yeah, that was I was quite shocked, but yeah, no, it was really amazing, and also a cash prize, you know.
Cash prize never goes amiss.
No, I didn't actually. It was quite hard to actually hear what I'd actually won because I was quite far away, and then it wasn't until Ollie and I came off stage and were like, "What did we win?" And then they were like, "Oh, you won money."
Well, blame me for that. I was hosting, so I wasn't yelling loud enough. Clearly.
Yeah, but the award is really nice, and it's now on my stand. Looking very pretty.
Yeah, I'm sure we'll pop round later and have a look at that.
Yeah.
But no, it's a brilliant project. Really really, really out there.
Yeah.
Out of
quite,
this world.
Quite literally. And it's congratulations on the award.
Thank you.
Thank you. Thank you so much for coming on and sharing your project with us. Really appreciate it. We'll be back with another student in a minute. We're back with another student project. We've got Karishma with us. Karishma's got a Viva video, so we're going to play that right now.
Menopause is a natural event that happens to every woman as they head towards the end of their childbearing years. Menopause begins when a woman's ovaries decrease the production of female sex hormones, estrogen and progesterone, causing a reduction of eggs each month. A woman has reached menopause when she has not had her period for 12 months consecutively. This means her ovaries has not released an egg. There are 3 stages to menopause. Perimenopausal stage, when a woman starts to experience menopausal symptoms due to the hormone changes, but still has her period. Menopause, when a woman is in the process of not having her period for 12 months consecutively. And postmenopause, when a woman has not had her period for 12 months and after. When women enter the perimenopausal stage of their life, their female sex hormones, estrogen and progesterone levels fluctuate, triggering major physical and emotional health challenges that directly impact their relationships and well-being. This fluctuation is continuous throughout menopause and postmenopausal stages, with symptoms lasting up to a decade either side. A study from TUC showed that 80% of women experienced noticeable changes during the perimenopausal stage of their life. A survey of 2,920 women exposed that 66% of these women were incorrectly diagnosed with depression and were offered antidepressants by their doctor. Another survey highlighted the impact of menopause on a woman's family life, with 50% of these women saying that menopause affected their home life and intimacy with their partners, causing a tension in their relationship. The same survey also highlighted that 38% of partners felt helpless and did not know what to do. Despite being a natural event that happens to every woman, the subject of menopause is shrouded by secrecy and is seen as a taboo subject that women should not discuss. The consequence of this is that women are often felt unprepared and alone. The lack of information around these symptoms result in half the population suffering in silence and are caught off guard by the repercussions of these symptoms. Now presenting Alina, a discreet intuitive service that blends into the daily routine to help perimenopausal and menopausal women. This is achieved by tracking estrogen and progesterone levels through saliva. The continuous recording of users inputting their symptoms into the interface will allow for machine learning to predict upcoming symptoms these women might endure based on previous input. The predicting of symptoms will allow women to prepare themselves for any vasomotor, physical and psychological symptoms they might endure. Alina separates itself from existing products because it incorporates a combination of accurately tracking female sex hormones in women, qualitatively tracking women's mood and well-being, providing educational support and creating a community amongst the users. Offering educational and community support are vital features to help support women because it creates a safe space for women to educate themselves and not feel alone throughout the journey. Current existing services aimed at menopause only record their symptoms. They do not offer any analysis on their symptoms, meaning that women are missing out on vital information about their symptoms and their body. Alina is a 2-part solution, the first being a biosensor and sample sticks. The user will use the sample sticks to collect the saliva sample and insert them into the biosensor. The biosensor has 3 touch points: the on and off button, the timer function, which times how long a user should keep the sample sticks in their mouth, and sync button, which syncs the data from the biosensor to the interface. When the user interacts with the biosensor interacts back with the user. When turned on, the biosensor emits a white LED. When the timer button is pressed, the LED emits a green colour, and then a sound is played once the time is up. When the sync button is pressed, the LED turns blue, signalling to the users that the data is sent to the interface. The interface is where the results will be displayed to the user. The interface displays the hormone analysis to the user and breaks it down into accessible chunks of digestible information, so the user can understand how their hormones imbalance might affect them psychologically or physically, or both. The user will also be able to input information such as types of symptoms they experience, mood diary, food, and exercise regime into the interface. This creates a holistic image of their lifestyle, which can affect menopausal symptoms. The user will also be able to access educational resources and be able to communicate with other users about their experience, creating an Alina community. Alina means the beginning of thinking in a new way, and therefore it is time to stop shrouding menopause with secrecy and begin to look at it differently, and to empower women to stop feeling ashamed of their experience.
So that was Karishma's project, Alina, and I just wanted to ask, you mentioned that you've kind of tried to tackle the topic that's kind of shrouded in secrecy. How did you go about researching a taboo topic such as women's hormonal health?
So when I first approached the topic menopause, it was actually through family friends and my mother actually. So her and her friends were all going through it, and they were just appalled with the lack of research and lack of education out there. So I already had a group of supporters, so that was quite nice to have women who were ready to talk about it. And these women range from, they were like 35 all the way up to 80. So it was really great to have that broad range. And they also went through different life experiences. Some were from Canada, from India, and also with different backgrounds, which was really good, so it helped my research. But I also found on the internet that blogs, like women want to talk about it, but they feel like they don't have the space to talk about it. So a lot of blogs, Facebook groups, and you'd find that women do want to talk about menopause. So that's how I went about it.
It's a really interesting project, and obviously user experience and that kind of thing is very important, user input rather. Just wondering if there were any specific kind of user evaluation tools that you implemented to kind of help define your direction.
So I did a lot of user interviews and I did a lot of card sortings to help me figure out the key navigations. So on my application I have 4 key navs, and it was a lot of, I just had to listen to what the user wanted. I couldn't put, because I haven't gone through it and I wouldn't know. So it was a lot about listening to their key insights, and then from their key insights figure out what journey they needed to go on and figure out the interface through that journey and how each user would go through each step. So that's how I did it.
Yeah, trying to target this more sciencey side of it, I think your use of saliva is quite interesting for a measurement tool. Does it offer any specific improvement over like a blood measurement?
So the reason I went for saliva is because it's non-invasive.
Okay.
Blood is quite an invasive form of sample collection, especially if you want the user to do it each morning. Blood collection is good because that's what the hospitals use, but I wanted a solution where women can get up in the morning and it can fit into their routine. They can collect the sample whilst they're making their bed, and then it'll be done in one go. And this is better than urine because it's so much easier to put a sample stick in your mouth than it is to use urine collection.
Sure. One thing that you mentioned in the book actually is the name, Alina, at the beginning of a new way of thinking. I'm intrigued.
So I wanted to use a name that was different and stood out, but also not on the nose. I didn't want women to be annoyed by the name. And I thought, menopause is something that women need to think about differently. And the whole, not just women, men, people in the workplace, they need to understand that it's a life habit. People will go through it. It's puberty in reverse. So I think it's about time people think about menopause in a new way, which is why I chose Alina. So I liked, it was a name and it was still feminine but not in your face.
Awesome. Yeah. Very subtle.
Thank you very much, Karishma, for coming on and talking about your product. We really appreciate it. We'll be back in a little bit with our final for this half student project.
Thank you for joining back with us. We're joined now by Maria, who's our last student of the first morning sessions. We're going to talk about your project, Nexo.
Yeah.
So give me a little bit of an idea of what it's about.
So Nexo is a configurable walking aid that takes the individual user's parametrics, for example, their body weight, how much input they need, how much output, how much adjustability they need, and then that is input into the computer that then generates the specific design, and this is 3D printed. The individual user that then goes and it gets placed in the sock that is worn on a leg.
Awesome. So why 3D printing and what kind of 3D printing?
So this is using SLS, and
SLS, for those people that don't know, is
Really? You're throwing this on me?
What? Yeah, I don't know.
You tell me what SMS
Selective laser syndrome.
Selective laser syndrome.
You didn't know that, Toby.
Yes,
I know. I just want to make sure that you're not trying, to throw me under the bus.
Okay, fine. I'll take a step back. It's okay.
But yeah, what did you ask me again? Why 3D printing?
Why 3D printing and what kind?
Yeah, 3D printing was just because it allowed for basically to create a system where every product can be specific for every user. Most walking aids are just generic and they provide very low support, it's exterior, for example, walking aids, and so they're not specific for the user's needs. This way you can identify, oh, this person struggles going up the stairs, so I can adjust this specific section of the design and it can help the person in a more effective way.
I think the customizability is obviously a key point. It is the point of your product. But what kind of research did you do with people to kind of figure out their needs and how to adapt the product?
So most of my research was based off of research papers from elderly people, walking gaits, stair negotiation, what were the risk factors, where did they fall, and where did they struggle, to analyze how can I make a product that can be, with different constraints, can be 3D printed to be personalized for each specific scenario. So obviously not everyone struggles going up the stairs. Some people struggle with walking. So it needed to be something that could cover a wide range of elderly people problems.
Awesome. You mentioned parametric design, and parametric design is something that's kind of becoming slowly synonymous with this idea of mass personalization and mass customization. And I just wanted to know what kind of parameters on the product are being changed based on the user's specific requirements.
So the thickness of it changes depending on the user's weight, obviously, and when this is localized on the person's knee and leg. So at that specific point in your body, you tend to have 3 to 4 times the user's weight and forces being applied. So it needs to be something that can withstand the user's weight. So the thickness changes, the amount of loops in this section also change depending on how much spring back the person needs or how easy it is to bend. Obviously, if someone really struggles to bend their knee, they would want something that's easy to bend but also has some type of spring back. So this would be more of an option. It also changes in length and height depending on the user's specific measurements. And it also changes in terms of the angle on the middle section for shock absorption and also increased spring back.
Awesome. I know that you explored a lot of different options with this project, and for a little while you were kind of playing about with this idea of soft robotics and embedded sensors and stuff. Why is that not something that you chose? Why did you change tack?
Well, soft robotics industry is still not as advanced in terms of wearing something on your body that is not incredibly chunky. I initially wanted to use pneumatic actuators, but obviously to use that you'd have to have an air pump, and I thought it wouldn't really be suitable for a 6-year-old that already struggles with mobility to be carrying a backpack with, air just to help them. So I decided to go more in a flexure direction because it still gave the increased mobility and helped them and with spring back and all the things that they struggle with, but obviously is lightweight in comparison to having a pneumatic actuator.
Awesome.
That's really cool. So I think from me, I just wanted to ask how you went kind of about testing it and just checking that certain things you were doing for personalization was right, really.
So most of my testing was done through simulations. Okay. So I started initially figuring out the design because it had to be specific in order so that I could change it for all the different scenarios, as I said before. So I did simulations using a CAD model with different user weights, and then once I got a final design, I then simulated different scenarios. So for example, a person who maybe is weighs 80 kilos, is going up the stairs but has difficulty bending their knee. So I changed those parameters. I did 15 different variations and make sure that all the simulations were giving the results that the different parameters were setting out to do.
Awesome. A really comprehensive approach, I think.
Yeah.
There's one last question from me, because we've been having a little bit of fun with students' names.
Yes.
Not your name, the name of the product, to clarify that. Nexo,
Mm-hmm.
where does that come from?
Well, what have other people said that, did they say something very philosophical about their name?
It's been a combination of just puns, conjoined like words.
If there's a
foreign
legitimate
words.
meaning behind it,
Yeah.
there's some people who've got that as well, but...
Well, there's not an actual meaning. I think it came from a Portuguese word that I can't even remember what it was. It's like adjacent to is the original word, and then I played around with it. I wanted something like simple, catchy, and I was like, Nexo looks like the next thing.
Nexo, also you've got the connotations with like exoskeleton, this kind of thing.
Exactly. See, you already know my answer before I
There we go.
announce
Yeah,
it.
well,
Maybe you should take over my project.
I don't think that's a good idea. I think you've done an awesome job as it is, and I think I would do nothing but a disservice to it.
Yeah.
B, thank you very much for coming on. It's been a pleasure having you and talking about your project. As I mentioned earlier, that's going to be the last student project for this kind of half of the streaming, but we will be back at 3 o'clock, 3-ish?
I think, yeah, our second half of MIB TV today starts at 3 o'clock, where we've got some more student major project interviews, and then at 4 o'clock we've got our student-led programming, which again, I'm going to keep reiterating, you do not want to miss.
Do not miss it.
So make sure you tune back in for that. But until then, have a happy lunchtime, and we'll see you again at 3 o'clock.
Ladies and gentlemen, welcome back to the second half of our MIB TV schedule. Pav is with me once again. I don't think I'm ever going to shake him at this point.
Yes.
We're going to do one more hour of student interviews for their major projects before moving into our student-led programming. We've got a couple of things planned. We've already alluded to their not importance, their, can't think of the word. We don't miss them.
We've alluded to their spiciness.
We have.
I keep using the word spicy
that's
for a
one word
reason.
for it. Yeah, that's one word for it. But in the meantime, we've got Moritz here joining us on the sofa to talk about his major project. So Moritz, how are you doing?
I'm doing well, thanks.
How's the showcase
Good
been
to
for
be
you?
here. Nice talking to people and
Yeah.
lots of more and less well-versed people in design, and it's good to have a
It's awesome. Yeah, you're in the room next door as well, aren't you? Which is one of the bigger rooms in the large house.
Yeah,
and that's been a steady flow of people in and out.
Yep, always a couple of people about, and yeah, it's nice to speak to everyone and see everyone's projects as well.
Awesome. Yeah. So tell us a little bit about your project then.
Yeah, so I've been over the last few years really interested in using digital methods and data for producing products and implementing that in manufacturing, because I think it's can really create some more unique projects for individual users. And so this was in collaboration with Timberland Pro, so I was looking specifically at work boots and wanted to really define a very niche aspect to how we can improve the experience for a type of worker. And what I found is that there's lots of problems in the roofing industry with foot and ankle injuries and long-term musculoskeletal disorders. And yeah, so I made a mechanical solution that sort of adjusts to the specific gait on slopes and hopefully prevent some injuries.
Awesome. So it's an insert for a shoe,
or
that kind of fits in and around the foot. Can
Yeah.
you tell us a little bit about how the mechanisms work and they aid to kind of protect the ankle
Sure.
joint?
Yeah, so there's two aspects. One sort of adjusts to the environment a little bit more and is user activated, and the other one changes as gait occurs. So as the person walks, it improves the let's say properties of the boots to reduce the risk of falling and subsequent injury.
Sure.
I remember catching you once with a couple of 3D printed models, and I know that you were talking about like tension and specifically material choices.
Yeah.
What was that referring to? Did you sort out your problem?
Yeah, so to some degree, and it's all still, I think, under development to some degree. But yeah, I was experimenting with different rigid and elastic polymers to create something that can change as the mechanism changes and changes its position around the foot. And yeah, it's quite tricky to get it right to where the strength of the part is good, but also enough elasticity occurs. Difficult word.
Yeah, that's a tricky one. So a little bit of context for people watching. I know Moritz's project quite well, as I do with B, who was in earlier, because we're all in the same major project tutor group. And as with all our projects, 3D printing, additive manufacture played a big part in your major project as well. So I was just wondering what constraints and how you went about designing for additive manufacture specifically.
Yeah, so I think based on the use of SLS technology, the constraints are maybe a little less limited than in what you were working on with FDM, but subsequently more expensive, and that's why I really tried to home in on this mechanism design aspect, because you need something that's quite sort of high fidelity, something that's difficult to mold or make any other way. But yeah, and then looked into sort of nesting parts as well to reduce costs. Yeah.
It's very interesting, yeah. I have a question with regard to the visuals you've done. Honestly, is it a model or is it a render? Because it looks amazing, whatever's it is.
It's a rendering.
Oh wow, okay.
Overlaid on some images of the boots for reference.
Okay.
Yeah, I mean there were some mechanical models as well, but under development, these things are always maybe less attractive than you'd want to display them as, although very useful.
And the parts that you ended up making, how did you go about testing them? Did you do it? Was it all digital, or did you do any physical testing?
Yeah, so I did some printing of some initial mechanism and developed those over time, and tested out what worked and what didn't, and what breaks and doesn't, and what can carry the forces in tandem with simulation work.
Yeah. I can remember the little like locking leaf springy prints that you did. That was kind of the first thing that I saw you doing with like the support under the heel, and that's kind of progressed into the kind of flexural flex cam. That's the one.
Yeah.
So how does that work?
So it's a mechanism that changes based on the state of the ankle, essentially, and the rigidity of it changes. Yeah. So based on iterative simulation, so sort of a topology strategy to create new forms that iteratively improve, hopefully, over time. Yeah.
Awesome. Very cool.
Yeah. Very, very technical.
It is. Right, you're a product design engineering student, aren't you? You're one of those ilk.
The weird stories, whatever. I applied for industrial design actually at Brunel, and then changed to product design, and then changed to product design engineering.
You're all the way from one extreme to the other.
We'll find out, I think, what we're really good at. I think it's one of the benefits of the course, really, to have a broad thing that you can home in on what you really like to do.
No, absolutely. No, thank you very much
for
joining us today.
Nice talking.
We've enjoyed learning about your major project, and we really appreciate it. We'll be back in a quick second with another student project.
Welcome back to MIB TV. We're joined this time by our 6th Made in Brunel team member this year, Noah. How you doing?
Hello, I'm well, thank you. How are you two?
Yeah, not too bad. Not too bad. We're really getting into the student interviews. How have you found the showcase so far? You've been busy?
Fantastic, very busy. A lot of walking up and down a lot of stairs, but enjoying the show. Nice to see people face to face.
Yeah, that's the overwhelming thing, I think, that I've heard from a lot of people. Just the physical interaction, I think, has kind of made it all worth it.
Yeah.
Just by itself. But showcase aside, we're here today to talk about your major project, the Polo.
No problem.
It's an app-assisted product.
Yes.
talk to us about how the app assists the product and what the product is.
So, I guess the app assists the product. It's smoking. It's to empower smokers to finally put down the cigarettes and move on to a healthier alternative. So originally it was a just completely app-based product, but through the primary research conducted, it was discovered that a physical device would be necessary in order for a smoker to successfully cut down and to quit. So the behavioural aspects to smoking, such as the hand-to-mouth movement, as well as like the inhalation of nicotine, was like really essential. So that's when the physical form and like development of the physical device kind of started to then assist the app, and then it was nice to like integrate the two together quite nicely.
Awesome. So you mentioned primary research. What primary research did you do? How did you go about it?
So to begin with, it started with a survey to really get a feeling of user pain points and their motivations. So the two motivations that were I guess most impactful were the health effects as well as the monetary savings. I guess from the survey, a few short interviews conducted, video chats were conducted to elaborate a little bit further on some of the more qualitative sides of the questions. That's pretty much it for the primary research. And then when it came to usability studies and tests towards the end, again it's like a feasibility test, like task analysis, and that's
what kind of pushed you into wanting to do a project that tackled such a large problem, such as smoking? Obviously, it's things that have been. It's something that's been tried to be tackled quite a lot, and what kind of drew your attention to it?
So I had worked on an electronic cigarette project in second year, and I guess over my placement year I had kind of changed my decision on e-cigarettes and e-liquids, and I determined that they really weren't beneficial for smokers. They're probably just as addictive, and from what I found from the primary research was that people did feel they were just as addictive and if not more expensive than actually smoking cigarettes.
No, fair. It's fair. It's a good reason than any to really know. It's a statistic that you want to combat.
Yeah, it's a big issue, and I think trying to address the issue as kind of thoroughly as possible is really important. I think that's where the app comes into play. Correct me if I'm wrong, because that kind of maybe charts the user's progress with it. How did you go about designing the UI and making that as accessible as possible?
So I guess a major feature of the application is being able to monitor and track the consumption of these capsules I've designed. Some of the user testing came into play there regarding how I would display these graphs in a legible manner. I guess some of the other features include monetary savings as well as health recovery, as we just touched on. So in terms of the monetary savings, people can set targets depending on if they want to save up to buy a pair of shoes or a t-shirt, or something a bit more ambitious like saving up to go on holiday. They can set these targets to then, as they're using the system, they're just inherently saving money by doing so. It was designed to be cheaper than smoking cigarettes, so they're saving money by doing this. And then to touch on the health aspects, from the moment a smoker has their last cigarette, their body just starts to immediately recover. So these kind of milestones that a smoker would pass on this journey almost can be displayed, and the user can be notified of when they've reached certain milestones in their recovery, which was, I guess, to show the benefit of using the product over e-cigarettes or tobacco products.
So you made, or you designed the app in Figma?
Yes, Figma.
Which is a program that I think a lot of students have
We've had a couple of those so far,
how did you go about kind of designing it, making it, you know, all the way leading around to the kind of branding that you've chosen, this kind of blue colour.
Yeah,
it's
so
quite dark blue.
Yeah, so I mean, to touch on like the blue, really, it's definitely leaning more towards like the colour theory of blue with branding. It's a very pretty. I don't know where I'm really going with this, but yeah, nice, nice colour to use. In terms of Figma, it's just about getting in and really messing around with the UI and seeing what works, and then going back to users, seeing, getting feedback from them, and then iterating on this. I mean, the usability tests were essential. I mean, I mentioned about like displaying the graphs and data, so I had that was definitely the most challenging side of the UI, getting the data, like the graphs right. So first feedback wasn't necessarily as good as I'd hoped, so I was able to go back in and make the tables more legible, which I then went to show users again, and then received better feedback. So it was very much an iterative process, which ended up with a nice result that I'm happy with.
Yeah, I think the outcome is excellent. It's really, really high fidelity, really well executed. Something we've not touched on that you mentioned briefly was these consumable capsules.
Yes.
What was your development process for those?
So, in terms of inspiration, I kind of looked towards the e-cigarette market, specifically like Juul and some of the UK-based products. In terms of the capsule, they're pretty basic, I guess, in terms of their structure. The capsules are sealed with foil, which can then be pierced by the mouthpiece, so then they can be like air can pass through them and can be consumed by the user. On the underside of the capsules, it's not shown in the book unfortunately, but there's a little metal conduction plate, which then when is inserted into the pen, basically completes the circuit and then is able to be it informs the app that a capsule has been inserted, which then is able to monitor, that's how it's able to monitor the consumption. In terms of the nicotine, it's basically taken from kind of the nicotine replacement therapy market, so like the patches and lozenges that are readily available. There's also inhalators which use a similar technology in terms of condensed nicotine, which basically just vaporizes when it comes into contact with air, which I guess the foil plays a nice role of sealing this off until the user's ready to consume it, and then the user has around a 10 to 15 minute window to consume the nicotine inside, which again like closely mimics like actual smoking behavior.
Sure,
so that was what I was kind of aiming for with that.
Yeah, that's really cool. Yeah, it's a
Very
really neat
technical.
solution. Yeah. And you're industrial design, aren't you, Noah?
Yeah.
So it's quite a challenge to take on something like that from a more traditionally, human factors based.
I really enjoyed the developing the psychological understanding and designing for essentially changing behaviour and like intervening in like an addictive activity. It was really interesting. I really enjoyed the research side of things.
No, well, thank you very much for coming on. We do appreciate it. Thank you for coming on to your major project. We're going to be joined by another student in a quick minute. We're back with MIB team member number 6.
7.
7? I can't
Come on
count.
now.
No, 6. All right, 7. We're going to go 7 with Barney. And Barney's got a Viva presentation video, so we're going to be playing that right now.
This is a presentation about my major project. I hope you enjoy. The hairdryer is a product many of us use on a daily basis, but most of us are unaware of the poor design flaws and negative user experience. Continual growth in the hairdryer market can be seen through several market drivers. However, market growth fell by 4.3% last year in response to COVID-19. There has been no major product innovation in the hairdryer market in the last 60 years, with the only noticeable exception being the Dyson Supersonic. It Electronic waste is a massive environmental concern. In 2019 alone, over 52.7 million tonnes were produced, with less than 20% of it being fully recycled. In terms of per capita waste, the UK was only second in 2019, producing over 1.6 million tonnes. As can be seen in the bar chart above, this predominantly was in the form of small electronic products such as hairdryers and toasters. In March of 2021, we saw the introduction of the Right to Repair law, which will require all electronic products to be able to be disassembled and repaired by users at home. In user research carried out, it was found 3 out of 5 women perceive quality as a more important factor over price when it comes to selecting a hairdryer. With the issues highlighted, a redesign was clearly needed. However, using existing forms would be difficult in such a congested market. As a result, there was only one option: to completely redesign the hairdryer from the ground up. The end result is an elegantly designed product for the target market. The aim of the redesign was to create a unique and different user experience. This meant doing something entirely original, which resulted in a dual function and purpose product. This product can be used as both a hairdryer and a desk heater/cooler. A mode switch can be found at the rear of the handle. This enables the user to quickly change between product modes. Featuring at the front of the product is an LED ring. This is used as a visual clue to the user on the temperature of the product. Key to the design of the product is a modular component system. Once the dust filter has been removed, the user unlocks the product. The integrated bayonet fixings inside the product allow for a complete separation of all components. Individual components can now be repaired and replaced without the need of disposing of the entire product. For example, the fan blades can easily be repaired and replaced by simply removing it from the holder. Reattaching all the components is just as easy, as they are securely locked using the bayonet fastenings. Repeated product assembly will not affect the performance nor efficiency of individual components. The product comes in 4 colours: Pacific Blue, Space Grey, Jet Black and Pink Citrus. This project lasted 9 months, and despite everything currently happening, I'm extremely happy and proud of where this project has ended up. It is definitely a project I want to take forward into the far future, but that's something for another day. This has been a quick overview of my major project. Thank you for listening.
So that was Barney's Viva video, and now we got Barney here. So I just wanted to ask, what kind of thought did you put into the airflow of your product? Regards to like inlet and outlet.
Yeah, so when I was designing the form of the product, I didn't really want to go the traditional route of a handheld gun-like hairdryer. So trying to implement the sort of fan system was a little bit tricky. So the actual technology inside is not that complicated. It's just the fan, the heat elements. But when it hits the front cover of it, it sort of convexes over and forms in the centre of the product on the outside. And that is like 15 times more powerful than traditional hairdryers. So yeah.
Oh, that's quite interesting, yeah. And the form of the product is quite a striking form. I do like the form. Can you maybe show us with your hands like the scale of the product and chat more a little bit about the form?
Yeah, of course. So it's only, 150 by 150, and then the handle is, I think, 120 millimetres long. In the design process, it went through quite a lot of development in terms of scale, because the actual fan and the heater and stuff were quite big compared to traditional hairdryers. So trying to get the correct proportions between the handle and the actual technology was quite difficult. It was a lot of it was dependent on where the motor was going to go. So trying to get the motor as close to the hand as possible would not only improve the stability of the user, but also reduce risk of injury. So the motor had to be quite far forward into the product so the user could hold it comfortably.
Oh, okay.
It's really interesting because there are products on the market that we think, that's done. We've sorted that. We're finished with that. Hair dryers, for me, was one of them. So I'm intrigued to know how the idea came about of rethinking something that is, we thought we were done with.
Yeah, so the original idea started last August when placement work started to die down. And the more research I did, it sort of discovered that there were more and more problems found in hairdryers. So the actual idea of the sort of technology behind it hasn't been updated for a good 60 years. And then you've also got all the user experience issues like the handling, the wire, the aesthetics and stuff like that. A lot of companies will just do it in black for cost reasons, basically. And that's the main reason why you see hairdryers that have got no colour options. They just want to be as competitive as possible with other companies. So the idea was to try and make something completely new. Like I said, getting rid of the traditional hairdryer design, implementing new colour schemes, and trying to get a perfect user experience. So that's why it sort of developed into a unique hairdryer.
Yeah. Awesome. I think the other thing that I wanted to quickly touch on is, and I see it in your video as well, is your disassembly process.
Yeah.
You've kind of gone for the right to repair route and being able to swap out certain components when they break. How did you go about kind of doing that, and how did you basically design for that, basically?
Yeah, so the research also revealed that hairdryers can't be repaired, basically. Companies won't allow you, and even when I did the LCAs and stuff like that, they had security screws that you couldn't actually get into with traditional tools. So it sort of came about that, right, if I wanted to do something truly unique, the hairdryer would have to come apart.
Yeah.
And a good idea I came up with was implementing bayonet fixings.
Okay.
So once the user had turned it off, taken the power cord out, they could unlock the product component by component. So for example, if the heater did break, you wouldn't have to buy a new hairdryer, just buy the heater element and put it all back together.
Yeah.
And all the components are colour coordinated, so you shouldn't be able to make a mistake.
Alright, okay. That's good.
Yeah.
Yeah.
Not like a IKEA table.
It's all white.
Yeah.
Every part's white. Thank you very much, Barney, for coming on. We appreciate you showing off your product. We thought it was quite innovative, so thank you very much. Yeah. We'll be back in a second with another student project. Welcome back. We've got 3 in a row here in terms of MIB team members. We've got Joanna coming up with her project Tactus, and we've got Joanna's Viva presentation video to show you right now.
Boilers are complex products that can be hard to control and understand. This can be even worse for visually impaired users. Tactus was designed to give back independence in the home by allowing easy boiler control and diagnostic. Tactus can be fitted to an already installed combi boiler by a trained boiler engineer. The Tactus diagnostic device comes with 4 wiring pins on the back, and all 4 screws require being loosened to fit the wires from the boiler. Then, the wire from the boiler port 1 connects to the neutral port labelled N. The wire from the boiler's port 3 connects to the live 1 port labelled L1. The wire from the boiler's port 4 connects to the live 2 port labelled L2. Then the wire from the boiler's port 5 connects to the live 3 port labelled L3. The product is then mounted to a wall near the boiler using 2 screws. The flame detector is then placed internally at 6 cm away from the flame. The pressure sensor is then screwed to a T-pipe. The filling loop is then isolated so that the T-pipe can be fitted. Finally, the temperature sensor is removed from the backing and stuck to the hot water outlet pipe. Now the Tactus diagnostic device is fitted safely to the boiler. The Tactus Hub is a tactile device that can be fitted to any wall in the home. We make sure to discuss with the user the best place for them to access. Tactus is then mounted using 2 screws and the power lead is attached, meaning the device will never run out of power. The customer is now set with a tactile interface with a slider that is moved up to increase the house temperature and moved down to decrease the house temperature. If an issue arises with the hot water pipe, a bell noise will come from the hub. If there is a leak present and the heating system is experiencing low pressure, a low-pitched tone will play. If the heating system is experiencing high pressure, a high-pitched tone will play. If the pilot light fails to ignite, the hub device will buzz. Simply press the button to silence the device and a boiler engineer will be over with relevant parts and tools for your boiler's needs, reducing the costs and time of repair and keeping you in the loop.
So that was Joanna's Viva presentation for Tactus. Yes, Joanna, you are product design engineering, so there's a lot of technical aspects with your project, and you touched on them in your video. At any point with your design process, did you consult with boiler specialists, for example?
Yeah, I was actually really lucky because the project was a co-innovate project, and the university managed to get 2 companies that helped me. So I spoke to specialists from Switchy and specialists from Bosch, and they were both really useful because they gave different sides of how their products had done boiler diagnostics or not done it as well, and things they'd struggled with. So it was really useful.
Yeah. And what's the the biggest challenge that you've had to overcome during the design process?
Honestly, it was trying to get user feedback, because one of the hardest things is as much as we feel like we understand visually impaired people, we don't, and it's really sort of giving them the product and letting them touch it and watching how they interact with it. Because there was loads of things that I found quite shocking and I wouldn't have really thought of without managing to find people. And COVID made that much harder. So I ended up making loads of models and sort of posting them off to some visually impaired users that got involved.
That's quite cool.
It is. Your project, I've spoken to you a little bit about your project. However, I didn't know its name until it went in the book. And Pav, you whispered it earlier.
I whispered it.
Really got my attention. So, is there a story behind the name?
Well, the ridges were kind of added to the product on the tactile one, so on this one. And the ridges were added, and it kind of gave it a cactus look.
Okay.
But because it's a device that focused on sort of tactility for the blind, we kind of just went tactus. That's how it was made.
I just whispered it because I thought it was funny to just keep whispering.
To be fair, the whisper,
it does sound, yeah.
The whisper really adds something, a mystique to it. I imagine that. For everyone watching it in all the TVs, that's going to be terrifying.
Joanna, you want to look down that camera?
No!
No, I do not. Joanna, you're a product design engineering student as well, but the user experience stuff, design for visually impaired people, inclusive design, tends more towards the human factor side of product design. So how did you balance the two?
Oh, I literally did split it down the middle, because my supervisor and my second supervisor very much did both. So I spoke heavily to Federico sort of in terms of getting the embedded systems in the more sort of technical diagnostic unit, and then got some help from Richard Evans for the tactical side of it. Because I do really like both, because I really enjoyed my human factors module. So I took my two favourite modules and kind of squished them.
That's quite cool. That's quite cool. No, thank you very much, Joe, for joining us on the show and showing off your major project, Tactus. We'll be back in a little bit with another student project. Welcome back to another major project. We've got Tom with us, and Tom has a Viva presentation video, so we're going to be playing that right now.
Hi, my name's Thomas Sutton. I'm a product design engineer at Brunel University. And this year I've decided to focus my major project on ultrasound, its applications, and how I can further the field. Ultrasound is a world leader in non-invasive diagnosis technology. It is most commonly used in monitoring the development during pregnancy. But it can also be used to calculate blood flow to evaluate the heart condition, guide a needle for biopsies, and help diagnose breast cancer. To keep the image quality clear, the nurses have to constantly calibrate the equipment with an ultrasound phantom. Currently, there are several ultrasound phantoms in the market to calibrate dimensional accuracy, but there isn't anything to calibrate blood flow. So my major project is focused on developing and manufacturing a ultra-heart phantom with pulsatile flow called UltraHeart. The ultrasound heart phantom has three major components: the form, the electronics, and the ultrasonically sensitive materials. Form. This is a medical product intended to be used in hospitals, therefore it needs to fit its environment. The UltraHeart is white to show how clean it is, and square for ease of storage. I have made all the interaction points ergonomic and blue so that they stand out. I have also encased the heart in clear acrylic so that the user can visualize the blood flow. Electronics. The electronics include the Arduino, pump, and display. The Arduino is the brains of the electronics. It reads the dials to display a BPM and controls the pump accordingly. The LCD display shows a BPM and a graphic to give the customer a value to compare to their calculated BPM. The pump is a 12-volt peristaltic pump with the gearing to a maximum of 200 RPM. The RPM is comparable to the BPM. The ultrasonically sensitive materials. Ultrasound works by sending and receiving high-frequency vibrations from a piezoelectric crystal. To simulate muscle matter correctly, you need a medium and dampeners. The medium used in the ultrasound heart phantom is gel wax, and the dampeners are microscopic glass beads. Final product.
So that was Tom's Viva video for the Ultra Heart. Yeah, Tom, I just want to ask what kind of sparked your interest in ultrasound and improving its usability?
Well, it all started in my placement year. My placement year started at a lighting firm, believe it or not. But then I got furloughed and let go. During my furlough time, I worked at a 3D printing firm making PPE for the NHS. As I was there, I got an email stating that they were looking for people at Royal Brompton Hospital to make conversion units for ventilators, which was, right up my street. I was really happy to help. In a hospital, there's a lot of design decisions that I'm not particularly happy with, and thought that I could help. So they gave me a list, and that seemed to be the best one that I could produce at home, fully researched by myself, in a COVID environment.
Ah, okay.
Yeah.
I mean, you say easy, it seems pretty ambitious to me.
Well, you should have seen the rest of the stuff on the list.
Okay. Oh.
Yeah, it's a really phenomenal project, and we actually had Pete in earlier. I know you live with Pete, and Pete mentioned your literal home workshop.
We do, yes.
With something like an ultrasound scanner, it's very specific materials required. I believe you had a lot of fun with gel wax.
Yes, I had a lot of fun with gel wax.
Yeah.
I've still got 10 kilograms in a bucket in my bedroom, if anyone wants to buy some.
Well, you can look at that camera and pitch it if you want. But
never buy gel wax.
Okay, stuck with it now.
So the difficulties with working from home is the lack of access to workshops. Me and my flatmates made a workshop, don't tell our landlord. And
second time it's been mentioned. Yeah. I was going to find out. So.
I'm not sending him the link if you don't. So it was really interesting trying to overcome those problems. There was a couple of things that I knew straight off that I was going to be 3D printing 90% of the base. I went to Facebook Marketplace, lifesaver, got a heat gun to bend some acrylic, we got a bandsaw, real cheap, fixed it up so that we could cut a couple of things. But the interesting thing was gel wax is a hydrophobic but also very sticky material. So I couldn't do a lot of my manufacturing in an environment where there's a lot of sawdust, a lot of extra stuff. So the majority of my project was made in a more sanitary environment, e.g. my bedroom floor.
Yes.
So yeah, there was all those little complications that came with it, but I feel like it's worked out quite nicely. I've got a fairly decent model outside that some people seem pretty interested in, so I'm quite happy with the result.
Yeah,
awesome, man.
I was going to say it looks quite good on your stand and everything, so I'm glad to know it's all coming together.
It's been drawing a little bit of attention, which is nice. Get to talk to a couple of people from industry. And everyone seemed to have quite a positive response to it.
Awesome, man.
That's really good, yeah.
Great job.
No, thank you very much, Tom, for coming on. We appreciate it. We'd love to hear about your project.
Thanks for having me.
No, thank you very much. I think we've got one more student coming up for today. Yes. So we'll be back shortly.
Welcome back to MIB TV. We're joined by our last guest of the day, our last major project, which is Usman.
Hi.
Usman, how are you doing, my man?
I'm doing good, thanks.
This is your second day at the showcase. I saw you here yesterday.
Yes, it is the second day, yeah.
And how has it been for you?
It's been good on and off. People have been coming around asking about the projects.
Awesome.
So it's been good.
That's good to know. But we're here now to talk about your project, your major project. Yep. So what have you been up to this year?
So mine's called Horizon. It's a back-mounted polio vaccine carrier. I made it for countries in Southeast Asia and Africa where polio pops up every now and then. So I wanted to make a more efficient way of carrying and transporting the vaccine.
Awesome. So what kind of technical details were you implementing to ensure kind of safe storage and transport?
So basically the thickness of the box keeps the heat from the outside from penetrating on the inside. They've got 8 cold packs surrounding the vaccine to keep the temperature between 2 and 8 degrees.
Okay. Can you talk a little bit more about materials that you've used here?
Sure, yeah. So the actual container is made from HDPE.
Okay.
And most of the internals are made of the same. I've got some EPDM foam back padding so that when the user's carrying it's got some good back support and we've got some good shoulder support.
Oh, okay. No, that's quite cool. How are you? Again, I'm going a little bit more businessy here.
Go on.
As I do.
Go on.
How would this kind of product, obviously it is fairly medical, be kind of marketed out to people? Is it through an organisation? Is it through WHO,
It will
for
be
example?
through the WHO, for
Okay.
example.
I hit nail
They
on the
have it. They have an online registry of approved equipment.
Right.
So basically, you'd have to go through them to get any kind of equipment like this approved.
Yeah.
They'll put it up on their list, and then anyone who needs something like this would go through them.
Oh, right, okay. So you'd have people in your Southeast Asian countries.
So if any local agencies, like any smaller polio eradication organizations want to go through it, then they'll go through the WHO.
Oh, okay.
Yeah, so just out of curiosity, when product goes out to these countries, polio, from my understanding, obviously you're going to know more than me, but often occurs in these kind of developing communities.
Of course, yeah.
What kind of considerations were made to ensure that the product was resistant to any kind of shocks in those developing communities? For example, if things went wrong or if things broke, what kind of
every component has been built to be replaced if it's damaged or if it's lost. So every component is detachable, every component is replaceable.
Mm-hmm. So what did you start with then? What were the essentials? What was the skeleton? And then
the skeleton is basically, the main part is the box. So that's what keeps it. That's what holds the capacity. That's what holds the vaccine. Everything is basically slapped onto it.
Oh,
okay, cool.
Yeah. And I know you consulted a couple of people with coming up with this. What kind of help did you get?
So I got some help from experts in cold chain management. So the cold chain process is basically the start from the health centers all the way down to the actual recipient of the vaccine. So it's the process of getting to them, basically. So I consulted two experts who were basically in that field.
Okay.
And they helped me out with the not the design, but more of the general aspects of it.
Okay. So you made sure you hit all those points.
Exactly.
Ah, right. Okay. No, quite good.
Again, it seems to be quite a technical project. Lots of technical challenges, especially with regards to thermodynamics, keeping things cold and what have you. How did you approach that challenge?
So basically, I acquired some PCM packs. They're called phase changing material. It's a fluid that has a lower freezing temperature than water. So it freezes quicker than water, but it stays frozen longer than ice.
Okay.
I put that into a hot box at 45 degrees for 10 hours, just to see how it would do, and it stayed from 0 degrees to 8 degrees for that period. And the temperature range for polio vaccine is 2 and 8 degrees, so it was perfect.
Oh, so is that some practical testing?
Yes.
So that's actually quite cool then.
Yeah,
so
yeah.
You built a model then?
I built a physical model out of cardboard just to understand the size and shape of it.
Ah, right,
But
okay.
all the actual work was done on CAD.
Right, okay.
Also, what's your software of choice?
I use SolidWorks.
SolidWorks. Any surface modelling involved with your project?
Say again, sorry?
Any surface modelling involved with it at all?
No.
No? You lucky boy. That's all I'm going to say.
Final thing I think from me is I quite like your branding. It's quite striking.
Right.
What was the consideration that you kind of went into with why blue? Isn't medical more red? That's just a question.
Blue. I actually did some research into it. Blue is a very noticeable color with medical products, so I wanted it to be noticeable as a medical product, but not too similar to the colors now. I made it slightly darker, so it's a bit more distinct.
All right, okay. And the name Horizon.
The name Horizon, yeah. So
we like the names.
We do like the name.
Yeah.
The name, it's just significant of reaching new locations with this, because the idea is that because it's more comfortable, because there's more capacity, you can reach more places, you can reach more recipients. So it's reaching new horizons that way.
New horizons, there you go. I like that.
Awesome.
Yeah.
Great stuff.
Yeah, I love the logo as well. The logo's
Yeah.
really nice. So, yeah. Cool. Well, thank you very much.
Thank you so much for having me. Yeah.
And we appreciate you sharing your major project with us. That's it for today's scheduled major project, or students' showing off their major projects. We're going to turn over to our student-led programming in a short while. We've got coming up for you today, we've got the Women in Design podcast live, so that'll be coming up shortly. And then right after that, at around 4:30ish, we've got Above the Fried Chicken, which again, you do not want to miss. So make sure you're back to watch those shortly. But yeah, we'll see you in a short while.